All right, now that we practiced simplifying radicals, we are going to move into radical operations. So the first thing we're going to do is multiply radicals. So if we're multiplying radicals, we're always going to multiply the two numbers on the inside of the radical. So here we're going to multiply 10 and 2. And when we multiply 10 and 2, we get radical 20. Okay. Radical 20 can be broken down into a perfect square and another number. And that would be radical 4 times radical 5. 4 times 5 is 20. And the square root of 4 is 2. And we just bring our radical 5 down. And so this is going to be our new answer, 2 radical 5. Okay, again, if you would like to copy and paste all your perfect squares over, you can. I'm not going to write them out again, but if you want to write them out again or copy and paste them over to this, you can do that. All right, let's look at number 2. Again, we're multiplying the two numbers on the inside of the radical, and we get 6 times 3 is radical 18. Now, does 18 have any perfect squares in it? It does. Radical 9 times radical 2. And the square root of 9 is 3. And again, we just bring down our radical 2 because there's nothing we can do with that. So 3 radical 2 is our new answer. Okay, so 5 times 10 is going to give us radical 50. Now we're going to look at two numbers that multiply together to give us 50 besides 5 and 10, because we know 5 and 10 do, but neither one of those are perfect squares. So I would use radical 25 times radical 2. The square root of 25 is 5. And remember, I said whenever a 2 is under a radical, there's nothing we can do. So we're going to just bring that down. 5 radical 2. Okay, let's look at one more like this, and then I'm going to let you finish the rest. Okay, 8 times 3. 8 times 3 is 24. So we have radical 24. And again, 8 times 3 is 24, but neither one of those are perfect squares. So we're going to take out the perfect squares, which would be 4 times 6. So we have radical 4 times radical 6. And the square root of 4 is 2. And we just bring down our radical 6 because it cannot be broken down anymore. Okay, I'm going to let you guys finish 5, 6, 7, and 8. And I'm going to jump up to adding and subtracting radicals. Okay, so here's the trick when we're adding and subtracting radicals. It's the same as when we combine like terms, okay? In order to add or subtract radicals, you can only add and subtract to a number that has the same number under the radical. And actually, we're not doing anything to the radical itself. So let's pretend, before we jump into that, let's look at this. If I had 3x plus 4x, remember, I'm just adding the numbers in front of the x, and I would get 7x. We're doing the same thing with the radicals. Whenever we have a radical by itself, we can pretend that there's a 1 in front. So we have 1 radical 3 plus 2 radical 3. So again, we're just adding the numbers in front, and we get 3, and we're just going to bring our radical 3 along with it. Because we're not multiplying, we don't need to do anything to the radicals on the inside. 3 radical 3 is our answer. Okay? Let's look at 10. Again, I'm going to pretend there's a 1 in front. So I have 1 radical 7 plus 3 radical 7 is going to give me 4 radical 7. Pretend there's a 1 there. 1 radical 2 plus 6 radical 2 is going to give me 7 radical 2. Okay? And the same thing goes with the subtraction. So as long as they have the same number under the radical, we can subtract. 9, I'm going to subtract 9 minus 3 is going to give me 6 radical 3. And that's the answer. Okay. Same thing with 15. I can pretend that there's a 1 in front there. So I have 4 minus 1. Sorry, that minus sign is down so low. 4 minus 1 is 3. And just bring down my radical 5. So again, when we add and subtract, we're not doing anything to the inside of the radical, but we can only add or subtract if the radical is the same. So I'm going to leave 12, 14, and 16 for you to complete. And then let's look at when we're adding radicals and they are not the same. Okay? So first thing we have to do when they're not the same is we have to see if we can simplify them. So we know that radical 6 cannot be simplified. There is no perfect square in radical 6 that we can take out. So I'm just going to bring that down. Radical 6 plus. What can we take out of 24? Well, we know that we could take out radical 4 times radical 6. So we're just taking that out here, okay? Again, I'm going to bring my radical 6 down and my plus. What is the square root of 4? The square root of 4 is 2. And then I'm just going to bring my radical 6 down. So now I have 2 radicals that have the same number underneath. Again, I can pretend there's a 1 there. So now I have 1 radical 6 plus 2 radical 6 is just 3 radical 6. So whenever we're adding or subtracting, we might have to simplify the radical first if they're not the same, because it could end up being the same. Because in this case, we were able to get a 3 radical 6. So let's look at 18. 18, we have radical 3 plus radical 27. Well, we know radical 3 is going to stay the same because it's not a perfect square and we can't break it down into a perfect square. So let's just bring it down. Radical 3 plus. What can we break 27 down into? We have radical 9 times radical 3, right? And so when we take, I'm going to bring that down again. Radical 9, the square root of 9 is 3. And there's no square, we're going to leave the radical 3 the same. So now we have radical 3 plus 3 radical 3, or 1 radical 3 plus 3 radical 3 would be 4 radical 3. And that's your answer there. Okay, so let's try one more that has some numbers on the outside already. Let's look at number 21. I have 2 radical 6 plus 3 radical 24. Well, I know that 2 radical 6 can't be broken down because radical 6 is not a perfect square, and there are no perfect squares that I can take out of radical 6. So I have 2 radical 6 plus 3 times radical 4 times a radical 6. Okay. We've never seen this before. So now we have a number times a perfect square, which is radical 4, times a radical. So we have 2 radical 6 plus, I'm just going to keep it in parentheses so we can see it, 3 times, what is the square root of 4? The square root of 4 is 2. So 3 times 2, and I'm going to keep this as a times radical 6 for right now. Okay? So again, I have 2 radical 6 plus, well now I can multiply these two numbers together. I have 3 times 2, which is 6, times radical 6. So now I have two like terms, radical 6, and now I can add them together. So 2 radical 6 plus 6 radical 6 gives us 8 radical 6 as our final answer. Okay, let's do another one like that so you can see how we did that one more time. Again, and if you didn't catch it, remember you can always rewind. I'm going to try to do it quickly because I don't have a whole lot of time left on this video. But I have 4 radical 3, which I know can't be changed, so I'm going to bring that down, 4 radical 3 plus, and I'm going to put everything else in parentheses. I have 3 times 75. What can I take out of 75 that's a perfect square? I can take radical 25 times radical 3. Now I have a perfect square. 25 gives me a perfect square. So again, I'm going to bring everything down, keeping it in parentheses for right now. The square root of 25 is 5 times radical 3, because there's nothing I can do with that. But I can multiply these two numbers together, and I would bring my 4 radical 3 down, plus 3 times 5 is 15 radical 3. And now all I do is add the numbers on the outside, and I get 19 radical 3. Okay? I want you to try those. Same thing with subtraction. They're going to be the exact same way. So these are the addition and subtraction. So 19 and 20 are going to be similar to 17 and 18. And then 23 through 26 are going to look similar to 21 and 22. So if you need to rewatch the video to get a better understanding, please do so. You can also join my office hours Tuesday or Thursday from 1 to 2. Same Zoom. So it's an open Zoom. You don't have to stay the whole time, but if you have questions, I'm available. And then that way we can get through this together. Good luck. Let me know if I can help in any way.